Hey, geometry. Hope you're doing well. All right. Actually, I should have this in student view because you guys should be all set and ready to go so you can see exactly what, or I can see exactly what you should see. So we're going to start here in weekly learning as usual. And I know that we have not done so much with the cylinders today or last week, but we're going to catch up with them. So um, we're going to start here with this SLT 9 week 6 material. And I'm going to show you some things. All right. So here we are with our introduction. We are focused on this half today. Let me get my pen out so I can see. Oh no, I did not get my pen ready ahead of time. Welcome to Miss Homer's class. Here it is. Okay, so we are just focused on this half today. We will see each other together for this, so don't you worry about it. All right. So today you will be able to determine the volume of prisms. You will complete this lesson asynchronously, which is on your own. We do have some Cami notes in practice followed along with a lesson that is graded, and there will be a graded assignment, just part A, numbers 1 through 3. My internet wants to be slow. All right. And that looks the same. All right. So you have a choice here, right? We have a Desmos activity because I know some of you that like the Desmos activity. Some of you do not like the Desmos activity as much. So pick your favorite. So pick whichever period you're in. Anywhere you sign in, I will see your name. So please, no worries if it's the wrong one. But we have our Desmos activity here, which I'll show you in a second, as well as this Cami practice sheet, capture sheet for the formulas. When I click here, it will bring you to your Desmos activity on volumes of pyramids and cones here. All right, so our objectives today will be for you to be able to determine the volume of pyramids and cones, and you'll complete this lesson asynchronously, which means you can do it at night like I'm doing right now. Make sure to complete up to at least slide 14. Watch the videos, they'll be really helpful. Write down any questions you have so that we can discuss them on Thursday and Friday, and complete numbers 1 through 3 on this weekly assignment. So we have some warm-ups and some slides. Remember, go through at least 14. As we get up, the warm-ups, we're just going to discuss what the pyramid will be, as well as how to find the volume of a pyramid, a beautiful video done for your reference. So make sure you go through 14, and there are videos there with you. Now, some of you don't like Desmos, and you would prefer to do something with Cami. Oops, and it is locked until that time. All right, let me leave student view for a quick second. Oh, my wonderful coworkers. So this lesson, this video will be in here. They're just wonderful, and they really do a great job with these setups. All right, you can do your notes and practice assignment here. I want to show you a couple things on here so that if you are confused, you can refer back to this. I'm going to download this for a quick second so that I can have this and not have it mess up. You know how I do, guys. Don't worry. Today's no different, it being asynchronous. All right, let me open this so I don't accidentally write on the right one for my computer. Moments there, open. All right. So here in the warm-ups, we're just looking for the shape of the base and how to find the area formula for the base. Now, I know number 2 looks a little bit different. The shape of this base is a triangle. Feel free to type or to write, but this is a triangle, right? I know that it looks a little bit different from what we've been doing, but we have done triangular prisms. So the next step would be these triangular pyramids. The area for the base, the formula for the base is 1/2 base times height, because that's how I find a triangle. Don't worry, we're going to look into these a little bit more as well. Now, I know we didn't talk so much about circles, but circles are a big part of geometry, a big part of life, so it is a good one to know and to remember. The area of the the shape of this base, circle, that doesn't spell circle, and I'm going to leave it. Not the mistake, but the fact that I made a mistake because I'm trying to talk and write, and that doesn't work. Take that as a lesson. The area formula for a base, that is going to be pi r squared. All right, that is how you find the area of this base. Now, since you're watching this movie, let's figure out how to look this up, right? Because for number 5, it's definitely a different shape. What do we have? We have 1, 2, well, let's mark it 1, 2, 3, 4, 5, 6 sides on the base, right? If I do not know what that is, I'm online. I'm going to use it. A six-sided shape is a hexagon. Why isn't this clearly saying? But a six-sided shape is a hexagon, right? And what is the area formula? Area formula for a hexagon, something else that we can look up. Now, this is a bit confusing, I know, but it is just numbers, remember, and things that we can plug into a calculator. So 3 root 3 over 2 times A. And A is the side length. If it is a regular hexagon, what does it mean to be regular? It means that all of the sides of the hexagon are going to be exactly the same. It's regular. That is a fine formula. There are lots of different ways you can do it, lots of very complicated ways. And yes, I know I'm not unaware that I could just plug in a number here. If I said the side was 6, it's going to give me the area of this hexagon. It's okay to use the resources that you know. All right. So area of a hexagon, feel free just to type this in there. And I'll show you. All right, 3 root 3 root 3 over 2 times A squared. All right, and that is a hexagon. Oops, my A looks funny, but that is fine. All right, typing is totally fine as well. When we're finding the volume of a pyramid, just like when we're finding the volume of a prism, we have this big B, which remember is the area of the base, times the height of the prism, right? So that is the same. But if it comes to a point like this does, like this does, like this does, it comes to a point, then we are going to take 1/3 of it. That is always the case. 1/3 the area of the base times the height. All right. So I have full confidence that you will be able to find the volume of number 1 and number 2, and number 3 is just the same. I know it looks a little bit different, but it's still the same thing. Let's zoom in and play with it. And don't worry about the children, they are playing behind me. All right, so we have here, the area is going to be 1/3 area of base times my height. All right, so I see here my big B base. My big B base is the area of this triangle. We're going to pretend that it's drawn nicely. Well, the area of that triangle is 1/2 my base, little b base, times my height. Again, these are just of the triangle. This height here is not the same as this height here. This first height, or we could say that's your triangle height. You can make that note, whatever makes you remember, that's fine. And this is your prism, or your pyramid height, I should say. Whatever it is not necessarily the same height. So just be mindful that I am talking here about this triangle down here. All right. So I am, let's figure it out. 1/2 my base. That is going to be how long this is. Well, that is 12. 1/2 of 12 is 6, but I'm just going to keep going. And then my height of this triangle, it has to come down at a 90-degree angle, and it does here at 7.5. All right, so I don't want to do 6 times 7.5 in my head, but I have my Desmos calculator as a bookmark because I am so fun. All right, 1/2 times 12, I knew was 6, but that's fine, times my 7.5, and there is the area of my B, big B base. It is going to be, big B base is 45. So now I can plug this guy in for my big B, this guy, because those are all the same, right? We have 1/3 times 45, which is 15. But again, if you don't know that off the top of your head, you know, sometimes you like to do math in your head because it makes you think on long car trips. It's fun. And it's fun to be calculators sometimes, have a ball with it. But again, we can use a calculator. This is the height of my pyramid, right? So the height, how tall does this go? This is 10 millimeters tall. All right. So it may look tough with that 1/3, but 1/3 of 45, I will show you. 1/3 times 45 is 15. And then we multiply that times 10, and we will get 150. What is it 150 of? It's 150 millimeters cubed. All right, so those are how you will find the pyramid, right? We're just throwing a third in front of it. And yes, it's always going to be a third. Now, we kind of skipped over the cone life and the cylinder life. So let's check these out as well. The cones are the same way. This is technically the area of the base. This is my big B base if I wanted to call it that. And I do, so I'm gonna. So it is 1/3 the big B base times height. So it's the same exact formula. 1/3 big B base times height. In this case, my big B base is a circle. All right. But so plug it in either way. In the end, it's the same. But that's how math is. How do you remember it? How do you think about it? That is the important stuff right there. Let me get rid of that. All right. The reason I like that idea that it's 1/3 big B base times height is that I could always write that down. But I do have the recall that 1/3, that big B base is my pi r squared, and that is going to be times my height. I'm going to say big B base. I don't know why. I just love saying it, and I'm going to keep on saying it. So mute me if you want to. I'm just kidding. All right. So we have 1/3. I'm going to use this one because it does help. Pi r. All right. What is r? R is your radius. Now, some of you may be like, of course I know that, but of course I just want to be very, very clear. What your radius is it goes from that center of your circle to the outside. And that will always be the same. It doesn't matter where I go on my circle, my radius is always going to be the same length because every point on the circle is the same distance away from the center. That's what makes it a perfect circle. The diameter goes all the way across, right? If I had a line that went all the way across, that would be my diameter. I'm not looking for that. I'm just reminding you that's the diameter. So my radius here is going to be 9. And in this case, we want to make sure we square our 9. And then we multiply that times our height, which is 17. And yes, I want you to put this whole lovely mess into the calculator. All right. Yep, that's it. That's what I want you to do. Now, if you were like, but Miss Homer, the square root, excuse me, the pi is an irrational number and I want an exact answer. Okay, I'll play your game. 1/3 times 9 squared times, oh my gosh, my brain just went blank for a second, 17. Should have remembered that. It was my high school softball number. What? That is 459. 459. Now, I didn't multiply this times pi. So if I want an exact answer, that would be 459 pi yards cubed, right? And that's fine and that's lovely. Okay. But what does that mean in reality? Well, I know that pi is about 3 and 450 times 3, well, 400 times 3 should be about 1200, 50 times 3 should be another 150. So I could, have this estimate in my head. Or I could just multiply this times pi and get that it should be 1441.99. So I'm going to say that that's approximately 1441, not that decimal point there, decimal point here, 0.99 yards cubed. All right, so we'll do it that way. And there you go. All right, so you're going to do a little bit work with the cones. I want to try you to try a few of them. Remember, this here is actually your diameter, and that's not what we're looking for. We're looking for the radius. So if we take half of my diameter, that'll get my radius. So half of 27, which you can do as, in this case, would be 27 over 2, or we could think of that as 13.5, whatever tickles your fancy. Go ahead and do that. And the same thing here, right? They gave us our diameter, but we want the radius. All right, so these work. You should be able to, let me zoom out a little bit so we can see it all, see if there's anything else that you would like me to look at. We are just, if it's a pyramid, if it's a cone, it's 1/3 times the area of your base. All right, so you can show that here on this CamiDoc. If you don't like to write on these CamiDocs and would prefer to do the Desmos activity, that's perfectly fine. They are obviously the same ones because here we just did this one. So again, pick the way that you want to show it, but we would like for you to work through that by yourself. See how far you can get. Again, this other one we will work together with. And then finally, you will have, of course, there's extra resources because I have a fabulous team that gives you guys lots and lots of resources. So if you have more questions about the cylinder versus cone and all those, they're here. And then finally, we want you to get into this here. So there are 2 parts to it. Problems 1 to 3 are what you will be responsible for. And then we will work together to get through and make sure you understand the topics for 4 through 7. So that's what we need to work on today by ourselves. By Wednesday, Wednesday night, I'll see you all on Thursday so we can see how much we understand. Please feel free to email me with any questions, and I hope you're having a wonderful week. All right, take care of yourselves. See you on Thursday.